Hello everyone and welcome to this video in which we will almost exclusively be talking about Temporal. We're going to showcase two apps with Temporal implementation and explain Temporal key concepts along the way. We're also going to show you how to implement Temporal in an app with Bluetext. After the video, you should have a clear grasp on how to work with Temporal and understand what kind of real problems it's actually designed to solve. Temporal is a durable task execution platform designed to make complex, distributed workflows reliable, easy to build, and scalable. It's great for optimizing common business processes, like the process of ordering clothes online. Temporal is also built for long-running workflows like subscription life cycles, where customers can pause their subscription and resume it months later. Right now, what you're looking at is an app that I've created which displays 5 different messages. One is hard-coded in the API, one is stored in Couchbase, one is generated by the Faker package, and the fourth and fifth ones are generated by APIs. One is called the Pokey API, and one is called the official Dad Joke API. We have to press this button to generate the fourth and fifth messages. Although this is a very simple app, it provides a clear and practical way to demonstrate several of Temporal's key features. Because this app was created with Bluetext, we can open the Temporal UI from Polytope's Services section. What you're looking at here is a workflow, which is our business process. A workflow is what orchestrates our business process, and it decides what should happen and in what order. Workflows should be deterministic. Given the same input and event history, they must always produce the same decisions and in the same order. This determinism is essential because Temporal recovers from failures by replaying a workflow's entire history. Workflows contain logic for coordinating steps and handling retries and reacting to signals and events. They do not include external API operations like API calls, database queries, etc. All of this actually happens in activities. An activity is a task or action performed as part of a workflow. Activities can be used for non-deterministic tasks. They generally encapsulate business logic that is prone to failure. You can think of the process of ordering something online, where the payment might fail. Because our app relies on external data, it's a good example for demonstrating some of Temporal's features. In our app, the workflow starts when the user accesses the base route of the front end. When we hit refresh, the workflow starts, and it finishes when the last activity is completed. The process of generating, fetching, and displaying each of the 5 messages are activities within our workflow. Before we dive in and take an in-depth look at our workflow and how it's being executed, it is essential to understand the concept of workers. A worker in Temporal is an entity that, when ran, it establishes a long-lasting connection to the Temporal cluster, which it uses to continually pull for new tasks. To configure a worker, we would create a worker object, tell it which task due to listen to, which workflows it can execute, and which activities it can execute. So now we can take a look at our event history and what actually happened when we ran the workflow. If we look at the bottom, we can see our history here. The workflow was executed, so it started execution, the worker started executing the workflow, then the workflow task was scheduled, started, and completed. These are 3 different steps for any task. It gets scheduled by the worker. This is when the worker acknowledges, oh, okay, now I have to complete this task. When the workflow task actually starts, or the activity task actually starts, when the worker starts completing it, and then when it sends a signal that it has been completed. I then made our workflow sleep for a few seconds, which you can see here, the orange line. And then the worker continued to complete the workflow and then moved on to the first activity, which, as you can see here, is called Couchbase Message Activity. It scheduled this activity. The worker then started to complete it and then sent a signal that it was completed. Then the worker went back to complete the workflow until the next activity, which was to generate the fake data. So once it saw that the Couchbase message was successfully generated and displayed on the front end, it then went to start the activity of generating fake data, which again, it was scheduled, it started completing this activity, and then completed the activity successfully. Then the worker went back to completing the workflow until the next activity. The reason why I made our workflow sleep for a few seconds was just to demonstrate this temporal functionality. When the user refreshes the front end, it takes 5 seconds for the message to be displayed rather than displaying instantly. Once the generate fake data activity is completed, the worker continues completing the workflow until we send a signal. We also could have made the workflow sleep for this duration. Signals can be used to communicate with already running workflows. When I press the generate Pokemon name and dad joke, the workflow then continues to complete activities 4 and 5. As you can see here, the event type for step 22 of our workflow is workflow execution signaled. I just ran the workflow from the beginning so we can have a closer look at the UI, because when I initially ran it, I left a large gap between sending the signal, so it's less time stretched now. The reason I did this is so I can demonstrate that activities 1 and 2 happen sequentially. As you can see, the worker waits for couch-based message activity to be completed to schedule generate fake data activity. However, activities 3 and 4 happen asynchronously. They both start at the same time, and only when both of them are finished, the worker knows to complete the rest of the workflow. Now that we've demonstrated a rather straightforward workflow implemented in quite a simple app, we're going to go ahead and show Temporal integrated with a more real-world example. The example in question is a clothes ordering website that was created with Bluetext. We're also going to use this as an opportunity to show you how you can integrate Temporal and create a workflow with Bluetext. I'm going to go ahead and run my app again from the services section of the Polytope UI. And as you can see here, it's a very, very basic clothes store or clothes ordering platform where users have loyalty points, you can view their order history, and employees have the option to, or have the responsibility to ship an order. Only once the order is shipped after it's been made, the user has the opportunity to mark the order as delivered. They'll get a pop-up that essentially says this item has been delivered, and they have the option to say, yes, I've received this. And once they accept that, they have 15 seconds to decide if they want to keep it or if they want to return it. This simulates the sort of 28 or 30-day return policy that some companies have. And if they do choose to return the item within the time frame, they will not get their loyalty points. But if they don't return the item, they will get their loyalty points. As you can imagine, we use Temporal's sleep functionality for this specific part of the workflow. This app communicates with Couchbase, which is a database that stores all of our clothing information and dynamically changing stock. For this reason, as well as there being a payment option in this application, it makes it a perfect candidate for adding Temporal or orchestrating the workflow with Temporal. Let's go ahead and create an order, make a payment, and ship the order, and choose to not return the item, and see how the workflow looks. So we're going to go ahead and add an item to the cart, place an order, give, of course, completely fake card information. This is just a very quick mock payment. Then we get an order ID, which is also stored in Couchbase, and the employee view. As you can see, on the 11th of December, we ordered one item with a total of $15, and we're going to ship the order. Then if we go back to the customer view, we wait a few seconds, and then we get a pop-up that says, oh, DHL or PostNord has notified us that your order. Now, PostNord has notified us that you've received your order. Of course, it is not that realistic, but we will say, yes, I did. And then the timer on the front end begins. This timer is actually being handled by Temporal. It's the workflow sleeping for around 15 seconds. And now you can see we have 80 loyalty points, and if we don't return it, it goes up to 90. Of course, in reality, the process of receiving an email from PostNord or the process of making a payment would usually be handled by a third party, which makes it perfect for making it into an activity. However, because we're just prototyping quickly, the only actual external service that we're interacting with here is Couchbase, which, as I said, is storing our data and our user data. We're going to take a quick look at the event history and the workflow that we just ran when we placed the order and did not return it. Did not return the item. So it does look quite more complicated than the previous workflow. There are around 56 steps. However, a lot of the core concepts or features we demonstrated previously are still present here. For example, the signals, sequential workflows, and the sleep function. There actually is a fourth signal, that happens in this workflow, if we do return the item, that signal would then awake or cause the workflow to stop sleeping and not process the points. Adding temporal to our Bluetext project would look like so. We would run the add temporal tool, which runs temporal, Postgres for data storage, and the temporal UI, and then we can access them from the services section in Polytope as we did before. Add temporal client, which adds the client code for temporal to the project, and finally add temporal workflow, which actually scaffolds out a workflow. From here, we would open our preferred coding agent, for example, Klein, and ask Klein to make the changes needed to get our workflow to do what we want it to do. What I'm going to do now is load a very simple app similar to the message retrieval example we showed firstly, and add temporal to the application to demonstrate what the process is like. What you're looking at right here is an app that I just created with Bluetext. There's a hard-coded hello from the front-end message, a hard-coded hello from the API message that gets displayed onto the front end, and a hard-coded hello from Couchbase message that is being persistently stored in our database and gets fetched by the API and displayed to the front end. We want to make a workflow that starts when the user hits refresh, accesses the base route of the front end, and is completed when all three messages are displayed on the screen. Hello from the API will be one activity, and hello from Couchbase will be the second activity. When both of these are finished sequentially, then the workflow is finished. So first, we're going to run the add temporal tool. This starts a temporal server, Postgres for data storage, and the temporal UI, which we can access from the services section of the Polytope UI. Then we can add temporal client, which adds the temporal client code to our project. Right now, we can just see the Couchbase client code, but if we run this, we can see temporal client. Finally, we have to add the workflow. There is a Bluetext tool for this called add temporal workflow. We're going to name it messages flow. And then we can start with our prompt. Before we prompt the agent to make any changes, let's just have a look at what this actually did. So we can go to modules, API, source, workflows, and then we can see messages flow.py, which is our workflow that we just created. It's essentially a template that the agent will build on from here. So I have prepared a prompt and I said, I have temporal up and running and I've created a messages.py workflow file, a messagesflow.py workflow file. Create a workflow that starts when the base route of the front end is visited by the user and ends when the final message is loaded. First, the API message activity, which fetches and displays the API message, should complete. Then the Couchbase message should complete in a separate activity. We're going to wait for that to generate and have a look at what our agent created. So taking a look at our workflow, we can see that the workflow starts when the user accesses the front end for the first time, when the fetch API message activity gets scheduled, started, and completed, and the same for Couchbase. In theory, you may not use temporal for such a straightforward implementation, but because of its retry logic, if, for example, we lose connection to the Couchbase database for a few seconds, the worker can retry the activity from the beginning. You would set a timeout either from the schedule to start or schedule to completed or start to completed. If these tasks exceed the timeout limit set, then temporal marks the activity as permanently failed. When an activity fails, we can view details like last error exception from the worker, for example, if there was a connection issue with Couchbase, and the retry count and timeouts that were exceeded. I do hope that by watching this video, you've been able to understand some of Temporal's key concepts, been able to understand what Temporal actually is, how companies or enterprises can benefit from Temporal, and how to actually implement Temporal in a Bluetext application. Thank you very much for your time.